Hi everyone, I'm Imogen from Course Report. We are a resource for researching which technology bootcamp is right for you. We have a directory of different bootcamps which teach everything from coding to data science and cybersecurity, plus a blog and interviews with founders, instructors, and students. All of these things are there to help you work out which bootcamp you want to go to. Now, most people who are enrolling in a bootcamp want to change careers, so knowing how to ace the job interview when you graduate is an important concern. Today, we're going to talk about data science job interviews, including what to expect in terms of questions and structure and how to prepare for them. So today we have Andrew Savage from Metis Data Science Bootcamp with us, and he is the head of employer partnerships and the senior career advisor. So thank you so much for joining us today, Andrew.
Yeah, thank you so much for having me.
So we talk a lot about coding bootcamp graduates and about the technical interview, those infamous coding challenges, whiteboards, etc. But what are the actual components of a data science job interview?
Yeah, generally the data science job interview is split into 3 different parts. Most typically take that fashion. First round is generally a phone screening, typically held with a recruiter or HR person. Sometimes it is with the actual hiring manager. And these are oftentimes, somewhere between 30-minute to an hour-long conversations to get to know each other, to understand you as an applicant, your background, to talk about projects you've done and other things like that. And really to kind of, understand more about the company, how you could be a relevant problem solver for the company, express your interest in why the company seems like a good fit for you. So generally it's mostly chit chat and getting to know each other and things like that. From there, most of the time there's some sort of take-home challenge. This usually consists of like a live coding challenge where someone can see your code in kind of like the language usually of your choice, but oftentimes it's either Python or SQL, we've come to find. And another type of take-home challenge aside from live coding is, a take-home data set where a company might give you a actual version of their data set or some sort of copied version that kind of acts as a replication for you to solve something. So it could be like, here are all of our, information about our users. We want you to find the features that lead to, increased viewership or something like that. Write it out in code, present it to us, send it back to us so we can evaluate. And then third is generally an on-site, which does consist of a mix of technical and behavioral questions. It can very often include whiteboarding as well. And that can be, again, one round or several rounds with a wide variety of people.
So who usually conducts the interview? Like, is it usually a hiring manager or like a team lead from the company?
The on-site interview is almost always a team lead, at least to begin with. Sometimes a colleague who you'd be working with directly. So the data science manager or senior data scientist or someone who's in a principal lead is often going to be kind of the main point of contact, at least initially. They'll be asking you questions that are relevant to your day-to-day work, what you'd be trying to solve for. They could quiz you on your technical knowledge and ask you a whole host of different questions along the way. But oftentimes it's not limited to that person who could be more of a managerial or supervisional person within the data team. Because data science is just so amazingly complex, and it really is a field where you're solving a great magnitude of different types of questions that affect different departments. You could be solving data science problems that affect marketing, that affect product development, that affect sales or engineering teams. Oftentimes you might be asked to meet with those people as well. And each of them have their own kind of things that they're looking out for, that they want to communicate with you, ask you questions about, Really, it will depend on the data science position that you go after, what interactions you would have with those teams, and being able to kind of be, as you oftentimes are as a data scientist, the point person who is responsible for solving problems that, yes, are part of a core data science team, but have implications for many other teams as well.
And then how long does the whole interview process usually take, including all of those stages that you mentioned?
Yeah, altogether, it's definitely at least a full day's worth of work, if not more. The phone screening is going to take 30 minutes to an hour. The take-home challenges, oftentimes, if you have a live coding situation, it might be limited by a certain amount of time, so maybe an hour or 2-hour format. If it's a take-home data set, that's where things can sometimes get a little bit tricky, because some companies will say, get this back to us within 48 hours or get this back to us whenever. They don't give you a time frame. So you're kind of left to your own devices to decide how much time you should spend actually working on that data set. Because as you can imagine, to make everything as perfect as you would like it to be might take many hours. But in general, no data set take home should take you more than 10 to 15 hours of your time. It should be, an involved exercise, but it shouldn't dominate all that you do for a week or longer, even if they don't give you a timeline around it. And then the on-site, at minimum, you can expect at least 2 hours for an on-site. There are definitely a number of companies that, because you'll just be meeting with so many different people, you can have 6, even 8-hour on-sites, so full day on-sites. And you have the possibility of returning for multiple on-sites. So it might be a collection of 2 or 3 hour long interviews with different people over different days. But in general, you should expect at least 2 to 6 hours to be dedicated to the on-site stage.
And then does every data science job interview include a technical portion? And if it doesn't, is that a kind of a warning sign?
There should always be some sort of technical component that, if nothing else, quizzes your knowledge around technical matters and also asks you to explain your thought process in terms of how you would solve for a problem that they are actually trying to solve. Whether that means that you actually have to go up to a whiteboard and start sharing your code with them or working through an algorithm, that's their determination. Sometimes they'll see your code before you get to the onsite because of a technical take-home challenge, so they can see your code before they meet you in person. But there should be a technical component, and if there's not, I think that is a little bit of a red flag where you might want to ask yourself, does this company really know what they're looking for, and do I match the skill set that they would actually need to get what they're going after to have that be accomplished?
Yeah, that makes total sense. And then I wanted to talk a little bit more about interview questions now. Mm-hmm. Would you be able to give me a couple of different examples of the sort of interview questions that people can expect when they're interviewing for a data science job?
Yeah, absolutely. And just maybe kind of like in order of the general types of questions that one can expect to face. Almost every interview starts off with some level of what I call kind of like a chit-chat question. Something that allows you to connect with your interviewer, to talk about yourself, to talk about things that you've been doing in the past. And of course, it's kind of, your answer should always be phrased to kind of fit within the bubble of what that company is trying to achieve, because that's really how you sell yourself and your ability to solve their problems. But oftentimes, you're not going to, answer the phone or walk into a room and be asked right away, like, here's this problem, solve it for me. Generally, there's a little bit more kind of conversational nature. So a chit chat question that you might expect to get could be something along the lines of, so tell me an interesting technical problem that you solved. So this can cover any number of things, but essentially, a question like this is meant to elicit a response from you that your interviewer can see, you having faced some sort of technical challenge in the past and having you share your mindset around how you approach that problem, what things you took into consideration, what methodologies and modeling that you used. Oftentimes, if you can, you're going to want to phrase it in a data science context. It doesn't have to be a data science context, but if at all possible, you want to talk about a project that you did that is relevant to that company and to that position. And the best way to do that is to highlight something technical in nature that you solved, that you sought out to do, that is relevant as possible, as relevant as possible to that company. So it could be a previous work experience. You could say, hey, at my former company, I was presented with having to build or manage this product and do some analysis around that. Or it could be a project that you developed on your own. So in the case of Metis, we have all of our students do 5 different data science projects that cover like a wide variety of different topics, different problem sets, different data types. So for them, they have the ability to kind of talk through the full cycle of approaching a data science problem, from data gathering to feature engineering to applying the right modeling to interpretation to iterating on that design and all that goes into a normal data science project. So they have that ability to maybe talk about that as a technical problem that they solved. And yeah.
And then I think you had another example as well, right?
Yeah. And just along those same lines, so less of a chit-chat question. From there, you may expect to be quizzed on your technical knowledge of things. So, in that process of storytelling from the previous question, the chit-chat question, they might poke and prod for your knowledge, and hopefully it's something that's relevant to what the company is doing as well. This kind of a general knowledge question. You could get a question like, hey, describe the differences between supervised and unsupervised learning. So this question or others like it are really meant as what I would say are kind of filter questions to determine whether or not your knowledge of the area is legitimate or not. So for any data science interview, a question like knowing the difference between supervised and unsupervised learning, being able to describe it quickly and accurately is going to be something that could be expected. There's a number of other typical types of questions, but it's one of those kind of benchmark questions where if you know it, you know it, and if you don't, the interviewer may feel like you're trying to pull one over on them. So it's good to anticipate questions where you're going to have to give, it doesn't have to be a textbook definition, like you don't have to give, whatever you find in some sort of encyclopedia or data science resource, but you're going to need to explain very clearly what are the differences, why unsupervised learning has the characteristics it has, why supervised learning has the characteristics it has, and things of that nature, as well as potentially, dropping in any experiences you've had, where you can talk about working with one versus the other or both. So it's good to prepare for those because you don't want to dance around a question like that. They'll be able to determine whether or not you're telling the truth.
Yeah, and then I know at Metis you teach Python, but I was wondering if your students ever interview for R jobs and whether they need to prepare for that eventuality.
I'd say over time, it's becoming less and less the case, although R definitely has its advantages over Python and vice versa. Python has its advantages over R. Generally, what we come to find with the employers who I work with, at least, not too many of them, hardly any, a very small minority, I'd call it less than 10%, have a strict R or nothing requirement. It was more about 2 years ago, but lately it's kind of Python and or R. Usually there isn't kind of like the specific need to have R only. And a lot of employers who I talk to say, hey, yeah, we've been doing a lot of our work in R, but if they do their work in Python, also. We are also confident that they'll be able to learn R over time. So if we really need them to operate within R, we feel satisfied with their ability to gain that knowledge over time. So in general, if a company is saying like, hey, we need to have someone who's fluent in R right away, then the vast majority of our graduates aren't a great fit, because only those who likely had those master's or PhD level degrees in kind of a quantitative subject will have had that previous experience. And if they need that skill level to be really good, upon being hired, then in most cases that's not going to be there. But if they're like, hey, you can work in Python and over time we'd love for you to switch into R, that's not too much of an issue.
That's awesome that that's possible. It's very cool.
Yeah.
And then what should an interviewee do if they get a question that they don't know the answer to?
If you can't, and you just draw a blank and you can't answer it, it is totally fine to say like, I don't know. It is, what you don't want to do is to just decide, I'm going for it, I'm going to blurt out an answer, because if you are wrong and you have something that is just not within the definition of what that thing is, it's one thing to be wrong, but you don't want to be wrong and reckless. So a strategy that I often tell my students to do is kind of know the nature of the problem. If there's the ability to kind of operate within kind of a gray area where you're kind of sure what that thing is or how to solve it, but you're not totally sure, it's totally fine to begin your answer by saying, I don't know exactly what that is, but my interpretation of what it is that you're working with this and that, or what have you. Or, you get a question like, write this out or solve this for me. You can say, I'm not totally sure the best way to solve this, but let me write out some ideas that I have and some ways in which I might go about doing this. At least by doing that, you're giving yourself the window to, the interviewer sees that you're going out on a limb, that you're not totally sure about what's going on, and they may be willing to kind of, watch you work through your methodology and your thought process, give you some breadcrumbs along the way, even if you're not totally going in the right direction. But the thing you want to avoid is just blurting something out and being reckless about it and being wrong, just because, you can really quickly lose the trust of the interviewer. If they get any type of sense that you're trying to pull one over on them, their BS detector is going to go off, and once trust is lost, the interview is effectively over. No one's going to hire someone who they feel is trying to pull one off on them. So,
yeah, I think that sounds like really good advice. And I want to stay on this topic a bit more. Talking about what interviewers are actually looking for. So, I mean, you were talking about what people should do if they don't know the question. They don't know the answer to the question, but have you actually ever been on the other side as an interviewer, and would you expect an applicant to get everything right in order to get the job?
Yeah, absolutely no. The questions that get asked on an interview, they're a mix of things. Yes, it's poking and prodding to kind of see what see what the interviewee knows with what's related to the job at hand. But it's also, in many situations, equal parts technical, related to the job itself, and also behavioral. And good interviewers, hiring managers know that you can hire someone who is A+, in the technical side of things, in terms of being able to know what to do, how to do it, etc., but who can really miss the mark in terms of, their fit from a cultural standpoint, from a behavioral standpoint, and things like that. So I think because of that, there's always a combination of, yes, we're looking for the right answer and we would love to see the right answer, but there's a lot of different things that are important too, namely being able to explain, how you solved a question, how you interact with others in the process of answering your question, how you communicate, and is it a conversational tone? Does it seem like a little bit of a adversarial tone that you have in terms of answering a question? So the short answer is no. There is some sort of baseline always, and that's going to vary from interviewer to interviewer in terms of, here are the things that you must know versus here are the things we'd like for you to know. And that's going to be individual to each interviewer in terms of what their threshold is. You're not going to know about that ahead of time, what their threshold is in terms of how many technical questions you need to answer correctly. But almost always in their evaluation, there's room for less than 100%. There's room for, hey, he or she arrived at kind of the wrong answer, but their methodology, their approach was really sound and I understood where they're coming from. And sometimes that's more important for their purposes than, acing the test, so to speak.
That makes a lot of sense. And I want to talk a bit more about the sort of non-technical skills, the culture fit type skills that interviewers are looking for. Yeah,
absolutely. Yeah, so it's always part of the equation for any company, especially, when it gets down to the on-site. It becomes even more kind of apparent because at the end of the day, yes, people are looking to hire talented people, but oftentimes hiring managers, the interviewers, they're looking to hire people who they're going to enjoy working with. It's a big investment from their perspective, financially, time-wise, emotionally, psychologically, otherwise. The people who you're going to be spending, 40 plus hours a week with, there's a lot that goes into determining who's going to be a good fit for that. And it's not simply a technical, meritocratic methodology, although of course technical prowess and ability to really solve problems well is super important. But there are a whole host of different attributes that I think are oftentimes most important and that companies, interviewers are kind of looking for within the candidates themselves. One of which is kind of curiosity and interest. A lot of people, get into the field of data science, especially increasingly in the last few years because, they have the technical background to get into data science. Data science has not been traditionally a field that you go and get your bachelor's or your master's for. It's been a kind of amalgamation of all sorts of different backgrounds and skill sets, people coming from chemical engineering or, political science and everything in between. So consequently, there are a lot of people who have gotten into data science because, I read that it was, this really well-paying, high level of satisfaction type of job. It uses my skill sets. So, okay, why not? I'll get into it. But good hiring managers, people who know how to manage talent, who know how to grow a team and interact, that in itself is not going to cut it for your reasons for getting into data science. They want to see that you have legitimate curiosity around the subject, that you're really interested in solving for the types of problems that you need to solve. And really importantly, curiosity kind of lends itself to passion, and passion kind of lends itself to being able to work through problems that you currently don't know how to solve. And for people who are passionate and really care and really curious about solving why this is working the way it's working or why it's not working the way it's supposed to, curious, interested people are going to have success in terms of like getting through that barrier. Whereas people who are just kind of doing it to go through the motions, they just want to be able to do something that they know that they're good at, they're going to hit their limit. And just by nature of how data science as an industry is moving, like every 2 years, you really need to add something to your skill set. Languages change, platforms change, ways of doing things and working with data changes. Nothing is static. And because of that, you're going to need to keep up. Sometimes your company is going to give you the tools and resources to do that. sometimes it'll be expected of you. You know, you're going to have to be engaged in a community, read open source, you know, documentation about what's going on. You know, so just like, you know, Spark has started to, you know, phase out Hadoop, there's going to be something that phases out Spark. There'll be, you know, all sorts of evolutions that are going to be necessary for you to learn. So, and curiosity and interest are really kind of at the baseline of that. Beyond curiosity and interest, you know, there's a whole lot of things that are important. Communicating your thought process, as we already touched upon earlier, is super important. You know, even though, you know, data science touches on statistics and coding, it's more than that. It's solving business problems. It's getting people to buy into why you're doing what you're doing, communicating to a technical audience and a non-technical audience. So being able to kind of see you know, the forest from the trees and communicate what's going on in kind of a grander scheme is super important. So, you know, there really isn't that much of a home for black box coders in data science. You really need to be able to communicate what you did. And importantly, you know, if you ever ship buggy code, something goes wrong, a company, you know, hiring manager wants to be able to know that you can tap into your communication ability to walk them through, you know, what happened, what did you do, why did you choose to script this in such a way that you did, so that they can kind of fix the problem or what have you. So communication of your thought process is super, super important. Also, you know, because data science is just such a broad brush of different things, you know, so many different types of data you can be working with, so many different types of modeling methodologies that you could apply. You really want to be able to showcase to your interviewer that you have relevant problem-solving skills. And what I mean by that is, you know, it's not necessarily, you know, oh, I've solved exactly, you know, I've worked with your data set before, like let's say you're interviewing at Uber. It's not to say that you have to be like, oh yeah, I've worked with transportation data before, I know exactly how to solve your problems. Yeah, that's nice and all, and that will be helpful, but I mean, you know, kind of stepping back in terms of what relevant problem solving means from a data science perspective, it really is more about the methodologies and the types of problems that you've solved before. So to kind of make an analogy, say you did some sort of project on, you know, the electrical grid. You're trying to forecast energy prices based on variable supply and demand for energy consumption. Inherently, you know, if you're just looking at the topic of that, you might think, oh, okay, that problem might only be interesting for a PG&E or a SunEdison or any number of large-scale utility companies. But the nature of the problem is a supply-demand question. It's, you know, trying to do forecasting, trying to understand, you know, a predictive nature around a price based on a commodity that is fluctuating. And a company like Uber could find that extraordinarily, you know, interesting and relevant for instance, their own surge pricing, you know, modeling purposes. They're trying to solve a supply and demand problem. So you need to think about how you've solved things before, what types of situations and problems you've encountered, and be able to make that link. You know, just because you developed a recommendation engine that was, you know, you recommended, you know, books to people, doesn't mean that, even as cool as that may be, if the company that you're talking to has no need or interest, it's just not relevant for their business problem to have a recommendation system, you know, there's a little bit of a mismatch. So you do need to kind of cover relevant problem solving with your company. And lastly, you know, just all importantly, this kind of goes back a little bit to the curiosity and interest aspect, but personability is super, super important. Not only just because, you know, data science is inherently communicative, you know, you're talking to a lot of people, you're going to have to ask, you know, and uncover what the nature of a problem is with your product people, with your engineering people, with the business people. And not only do you have to like listen to them and communicate your results to them, but, you know, personability matters, I think, in all aspects of any job that you go into. Being able to be someone who has a flexible mindset, who's willing to kind of be someone who others enjoy being around, talking to, bouncing ideas off of. You can be incredibly skilled technically, but it might be painful for other people to interact with you. So having personability, having the ability to kind of connect to and get trust and buy-in, especially in a data science role, is immeasurably important. So those would be like the main kind of 4 categories of non-technical things that you're often going to be kind of evaluated on, even though you may not be, you won't be told that you're being evaluated on those things, but those types of things are things you need to be mindful of and know how to kind of convey.
Oh, that was a wonderful overview. Thank you. I think that's going to be very useful for our readers and watchers. And now, we've talked about what to expect and what interviewers are looking for, but how can people actually prepare for one of these data science interviews to make sure that they actually, get the job?
Yeah, with regards to the preparation that we give to students at Metis, the way we prepare them is really multifaceted. Yes, we are looking for kind of like a baseline understanding in quantitative subjects, so like that linear algebra, statistics side of things, and proficiency in Python. But from there, what we're really trying to do is expand the bubble of knowledge in the fields that we find are most relevant from a job perspective in terms of what companies are hiring for most. So we focus a lot on applied learning, not a whole lot of time spent on the theoretical side of things, so that students can really develop projects that they work on from end to end, so they can touch on, exploratory data analysis, regression models, classification models, machine learning and natural language processing, big data. So by the end of it, they've all kind of had exposure, and they can say that, here's how I solved this type of problem. I had exposure here. Okay, I built a recommendation engine here. So it gives them a little bit more of an expansive bubble than others might get. Beyond that, it really is about knowing how to apply to jobs correctly, knowing how to utilize a community around you. It goes for data science, but it goes for all jobs in any field. Being able to leverage an existing group of people who can make introductions for you, referrals, makes all the difference. To be quite honest, quite often, the companies who I talk to, especially those here in San Francisco, they'll put a job online and get somewhere between 500 and 900 applications within the first couple days. There is no great way of filtering through that many applications from the perspective of the hiring manager. So it really does come down to getting a broader exposure to people who are decision makers, and that's something that Metis provides, both in terms of lending people our network, and also giving them tools to build their own network. So we bring a lot of industry professionals in to meet with students, to kind of broaden that opportunity in terms of applications. And there's a number of other things that we do in terms of workshops that we do that cover technical and non-technical matters, mock interviewing, so people get the foundation of how to explain the work that they've done, and how to approach certain common technical problems and questions that get asked on interviews. But beyond that, it's really just a whole host of different resources that we provide to them. Some of my, there's an unlimited number of different learning resources to kind of tap into. Some of my favorites for SQL, Mode Analytics does a fantastic job of giving people a further in-depth overview of how to work with SQL databases and covering that side of things, which oftentimes is a focus on data science interviews. So a lot of times I think students think, okay, data science is an evolution of data analyst work, therefore I'll never touch SQL again. Not the case at all. The majority of data science jobs still require SQL knowledge. So mode analytics is fantastic as a resource for people to cover there. Another one that I've really kind of taken a keen interest in, that I've felt has been well received by our graduates, is the dsinterview.com. It's kind of a gamified version of different types of quizzes and actual questions that have been asked at companies for data science interviews. So as you kind of go through that, you create a profile. It has like different levels of difficulty. It's very much a gamified kind of format too, so it's enjoyable and kind of interesting to walk through. And it'll actually tell you, this is a question at Google, this is a question at Facebook. So it really gives kind of a comprehensive overview of what's going on. And then just kind of like baseline, covers all the bases of data science, machine learning. Chris Alvin, who's very well known in the data science community, and just a great resource for all sorts of things for entry-level data scientists. His website, chrisalbin.com, if you go there, you scroll down, there's this a never-ending kind of list of different types of material that can be reviewed, from machine learning, linear algebra, statistical modeling of various types. He has wonderful machine learning flashcards that can come in handy, so that people can learn from as well. So those resources are really important as well.
Yeah, that's really awesome advice for preparation. And you mentioned preparing a data science portfolio. I was wondering what you tell Metis grads to put in those portfolios, especially if they're still pretty new to data science.
Yeah, so that's kind of a conversation that we have with them while they're still in the program. The 5 projects that Metis provides, the first 4 are very centralized in terms of the first one covers exploratory data analysis, the next one moves into regression modeling, and then classification and kind of front-end visualization development, and then 4th one is machine learning topics, recommendation engines, natural language processing, things of that nature. And then the 5th one is essentially a passion project. So for all of those first 4 projects, the students can actually choose the data set of their choice. We have a wide variety of public and private data sets that we allow our students to get access to. We also give them the tools to scrape data from the web, so they can kind of get access to data that they would like to work on. Oftentimes, it's a mix of, kind of encouragement in terms of what they focus in on. We want it to be something that is inherently interesting to them. Like, we want it to be a problem that they would like to actually solve for themselves. But at the same time, there's always the ongoing focus of, what's the business applicability of what you're doing? Could your entire methodology, even if you choose, hey, I'm going to work with, data on, hiking trails, and I just want to build something around that. Is this something that you feel you could confidently kind of talk about, in other interviews, that you could showcase, and kind of, put your name on. So that's what we're kind of focusing in on, is that mix of stuff that's very interesting, inherently kind of touching on subjects that our students are passionate about, because again, going back to that aspect of curiosity and interest really driving everything else. If they're not curious and interested in the problem, it can be tough for them to really go above and beyond and to get themselves unstuck when they inevitably do get stuck. But we do also want to be, practical with them. And so myself, our instructors, our data science instructors, meet with each and every one of them to examine, what's the data set you're working with? What's your plan? What metrics are you looking to kind of choose? Because that whole process of choosing your metrics, knowing what you're trying to solve from the get-go is, it's crucial to data science work being done correctly. So that's essentially kind of how we guide them in terms of their project and portfolio development, so that by the end they have 5 different projects that touch on things that they're both interested in and have a wide variety of kind of business applications, and go from everything from machine learning to other types of modeling, so that they can have the best chance possible of when they actually go on an interview to meet a company, meet a team of data scientists who are doing something that they have already done.
That's wonderful advice. Yeah, that all makes so much sense to have a varied portfolio like that. We're at the last question now. I was wondering what your sort of advice to employers who are hiring data science bootcamp grads would be.
Yeah, it's similar to similar in many ways to just how they would hire anyone, but what I would say is to be open-minded with regards to who might come through a bootcamp or any other type of immersive program. At Metis, we've had students ranging in age from 19 to 60 some odd years old, from people who haven't even completed their bachelor's to people who have PhDs in statistics or computer science, and they're looking to get into the data science field. So obviously people are going to have their strengths and weaknesses just like anyone else. But we've been able to place all different types of folks into data science roles regardless of what their background is. And we do a really thorough job of vetting out who's going to be a good candidate for learning the process of data science. And that's not restrictive with regards to age, background, or level of advanced degree or what have you. So what I would say is keep an open mind with regard to anyone who may kind of, especially people who are mid-career transitioners in doing that type of work, and just more kind of specific advice with regards to how to conduct an interview. And this goes for bootcamp grads, it goes for anyone. Please do, focus in on what is actually essential for your employees to perform on the job. A lot of people don't have a lot of background in how to conduct an interview properly, and they may ask pie in the sky, impossible question just to kind of see how people react and squirm and kind of solve something that is either really, really difficult and or irrelevant completely to what would be expected of them on the job. So make it practical, make it kind of on the job, relevant questions. If it's something that you would be totally fine with them, Googling or using Stack Overflow to find on the job, why ask them, that same question and expect them to give a great answer right then and there? So, make it practical. Yes, it should be challenging, but it should also be relevant. So that would be kind of my words of advice for any potential employers.
Yeah, I hope people heed your advice. It seems like very good advice. Well, that's all of my questions. So yeah, I think we've covered a lot of really great stuff. I think anyone who watches this video is gonna hopefully feel a lot more prepared for a data science interview. So yeah, thank you so much, Andrew, for chatting with me. I really appreciate it. This was really informative. And I'll put a link to the slides and a transcript for people if they are watching this video. So yeah, thank you so much.
Yeah, my pleasure. Thank you so much.